What's going on, Algebra Bros? It's Mr. C here, and in this video, we're going to knock out 3 quick and easy examples of logarithmic function inverse properties. I didn't want that to roll off my tongue that way. We are going to knock out examples involving the inverse properties of logarithms. There we go. All right, let's begin. Example 1, we want to evaluate the natural log of e. All right, so we know from a previous video that this is a committed fact. All right. In other words, the natural log of e can always be replaced with the number 1. But if we want to see why that is, perhaps using an inverse property, note that we could write the natural log of e as log base e of e. And I'm going to put a power of 1 on that e. Now this looks like the second inverse property that we discussed in that previous video, which says that if the base of the log matches the base of the exponential, then the log notation cancels out the base inside the argument, and the power comes down and becomes our final answer. So in other words, log base e of e to the first is equal to the number 1. All right, so kind of a double verification on that fact. For example 2, we have 5, and in its power, we have log base 5 of pi. All right, let me rewrite that so that you can tell that the log base 5 of pi is in the power. So I'll write a bigger 5, and in its power, log base 5. In the argument, I'll put pi. All right, so this resembles that first inverse property. Notice that the base of the exponential 5 matches the base of the log. So we more or less get to cancel those notations out. And what happens is the argument of pi is going to come back down on the ground and represent our final answer. All right, so a little bit of canceling action happening in this one as well. For our third and final example, let's rewrite this as e, and in its power, log base e, and the argument is going to be x squared. Okay, so this is very similar to problem 2 in this video. Notice that the base of the exponential matches the base of the log, so we get to cancel them out. And what's going to be left over, representing our final answer, is the argument that's in that log, which is x squared. So in other words, e to the natural log of x squared simplifies to x squared. All right, let me know if you have any questions about these examples. Otherwise, I'll see you in the next one. Thanks again for watching.